Good morning. This video is to review how to find the area of triangles and trapezoids. So before we even go into the formula part, you know me, I like to show the how and the why and explain. So if you look here, quadrilaterals, we talked about in the lesson today, how to find the area of a parallelogram. And to do that, you just multiply the base times the height. And when you put two triangles together, you get a parallelogram. So to find the area of a triangle, you just multiply base times height. But you don't have a parallelogram, you have a triangle, which is two triangles put together. So we would just divide by 2. And then looking here at these trapezoids, the same property applies. When you flip them over and put them together, you get a parallelogram, base times height. But here you've added base 1 and base 2. So that's why it's bases times height, and then you divide by 2. All right, so here are the formulas once again to find the area of a triangle. Area is big A. You take half of the base multiplied by the height. I've seen this formula written so many ways. Another way people like to do it is they like to say base times height divided by 2. Both of these work. When it comes to area of a trapezoid, capital A, the big area, is essentially the same. You're taking half, but this time you're adding the bases together, base 1 plus base 2, and then multiplied by the height. So again, another way to write that is base 1 plus base 2 times height divided by 2. I like this. This is my method. I memorize it easily. All right. Now, critical thinking problems. There's going to be word problems coming up, and I don't want you guys to struggle. Think about it. What happens to the area of a triangle when the base is doubled and the height remains the same? Draw a diagram and use an example to justify your answer. Okay, so I'm going to draw a triangle that has a base of 4 and a height of 2 centimeters. All right, so I'm going to draw my little line like that to show the altitude. All right. So if the height is 2 and the base is 4, then the area of this triangle would be half of 2 times 4, 8. So the area of this triangle is half of 8, which is 4 centimeters squared. Remember, area is always measured in squared units. So if I were to double the base and keep the same height, what would happen? So I'm going to do that over here. So I'm going to double the base. I'm going to make my base 8 centimeters this time, and the height is going to remain 2 centimeters. Something tells me the area is going to double. There's my height. So again, I recommend using rulers. Use your toolkit. That's what they're for. Okay. So my area is going to be 1/2 of 2 times 8, 16. Half of 16 is 8. And yes, look at that. So when you double the area of the base, the area doubles. Let's look at the next one. Think about it. Describe what happens to the area of a trapezoid when the length of both bases are doubled and the height remains the same. Draw a diagram and use an example to justify your answer. Okay, so let's see. I'm going to do the base 1 of this trapezoid is going to be 1, and the bottom is going to be 2. Whoops. And the height, oof, I should have measured the height first. I'm going to do that first. Okay, base is 2, and the height is going to be 1. There we go. And the top base is going to be, let's have it be 1. Okay, there we go. There's my trapezoid. The more you use your toolkit and practice, the more comfortable you'll feel. All right, so there's my trapezoid. That's good practice. So here's the formula. I always write the formula out. That way I can just plug my values in. So area is going to be 1/2 of 1 plus 2 times 1. So I'm going to take half of 3 times 1. So half of 3. So the area of this trapezoid is 1.5 centimeters squared. Okay, so we're going to double now both of these. We're going to double both of the bases. So my top base, wait a minute, I should start with the bottom. So 2 is going to double to 4. My height is going to stay the same at 1 centimeter. And then I'm going to double the base at the top to 2 centimeters. All right. Beautiful. So 1, 2, and 4. So again, if I just plug in the values into my equation, my area is going to be 1/2 of 2 plus 4 times 1. So half of 6 times 1. So my area is going to be half of 6, which is 3. And 3 is double 1.5. So the same thing happens. So interesting to note that. Ooh. And that's all I got. Huh.